All right, so good morning, everybody. So we're starting sphere, and this says a sphere is a solid shape in which every point on its surface is equidistant from a point within the sphere called the center. A sphere is a solid shape in which every point on its surface is equidistant from a point within the sphere called the center. Guys, the distance from the center to any point on the surface is called the radius. The distance from the center to any point on the surface is called the radius. Now, a hemisphere is a half of a sphere. A hemisphere is a half of a sphere. So I guess when you think about a sphere, you could think about a ball. A ball is a sphere. An orange, for most of the time, is a sphere or is spherical. All right. Now, so this point here basically is the center of the sphere, and the distance from the center of the sphere to any point on the circumference of the sphere is called the radius. This distance here is called the radius. I would say for obvious reason, but I don't necessarily think that it's not very obvious. But the distance from the center of the sphere to any point on the circumference, on the surface of the sphere is called the radius. Guys, the total surface area of a sphere, here I just have area of a sphere, is equal to 4 pi r squared. So in other words, the total surface area of a sphere is 4 times the area of a circle with the same radius. The total surface area of a sphere is 4 times the area of a circle with the same radius. Guys, now the volume of a sphere, V, is equal to 4 over 3 pi r cubed. The volume of a sphere is 4 over 3 pi r cubed. Guys, the unit of area is centimeter square. So you know that radius times radius, would be centimeter square or meter square or millimeter square. And whereas the radius of the unit of volume would be centimeters cube. So that is why the formula is 4 over 3 pi r cube. So it's radius times radius times radius, 3 times. All right, so let's have a look at example 10. I want everybody to follow this example. And then after example 10, you will do the question that follow. Example 10 says, the diagram below is a solid wooden egg holder. All right, so most people, many persons probably don't know what an egg holder is because we really don't use it at our home. But it's like a little device you put an egg in, maybe after you boil the egg, just before you crack it, you know what I mean, to sort of peel it and eat out the inside. All right, but it's an egg holder. So in essence, an egg is going to rest in it, as you're seeing in the diagram. Now the cup is a hemisphere. So in other words, the cup that the egg is resting in is the hemisphere. So the cup is sort of like that dugout area that the egg rests in, and the rest of the shape is a solid. All right, now the first thing we're asked to do, the radius of the hemisphere. So this is the hemisphere cup, and this would be like the center of the hemisphere, and the radius is 2.5 centimeters. The first thing we're asked to do is to calculate the capacity of the cup. So what I'm going to do, I'm going to let pi be equal to 3.14. So the first thing we're asked to do is to calculate the capacity of the cup. In other words, how much space, capacity is space, and space is volume. All right, remember the cup is a hemisphere, which is a half of a sphere. So the capacity of the cup would be equal to a half times the volume of a sphere, which is 4/3 pi r cube. Why a half? A half because the cup is a hemisphere. All right, so let's calculate. So we have a half times 4/3 times pi, which is 3.14, times the radius, which is 2.5, times 2.5. So I can multiply everything at the top. Well, this cancels this, 2. I can multiply everything at the top and then divide by 3. So let's do that. So this is 2 times 3.14 times 2.5 times 2.5, and then divide by 3. And this says, this is, I would say, 13.1 centimeters cube. So the capacity of the cup is 13.1 centimeters cube to 1 decimal place. What else want to find? All right, so as I said, imagine this thing. You have a cup, and then the rest of it is, the rest of it is a, the rest of it is a solid. So your thing looks something like this. It's a cup. The cup out area is where you put the egg in, and the rest of the shape is a solid. All right, the height or the rest of the shape is a solid, and the solid is a cylinder. The height of it is 6, and the radius is 2.5. So the next thing we want to know is what is the volume of the solid. The next thing we want to know is what is the volume of the solid. Tell me if you agree with me that the volume would be equal to the volume of the cylinder minus the volume of the cup. You can tell me if you agree or disagree. The volume of the solid would be the volume of the cylinder minus the volume of the cup. Guys, volume is the amount of space something occupies. So we have this cylinder, and then they dig out a cup out of the solid shape. You have a solid cylinder, and out of it, they dig out a cup. And the cup that they dig out is in the shape of a hemisphere. A hemisphere is a half of a sphere. So the volume of the solid would be the volume of the cylinder minus the volume of the cup. Do you agree or disagree? Anybody?
I agree.
All right. So the volume of the cylinder is what? A times H, which is pi r square H, minus the volume of the cup, we just calculate to be 13.1. So this is 3.14 times 2.5 times 2.5 times the height of the cylinder, which is 6, minus 13.1. So let's calculate. So we have 3.14 times 2.5 times 2.5 times 6 equal. So this is 117.75 minus 13.1. Let's see what we get. And the answer I'm having here is 104 point, let's say 7 centimeters cube. That's the volume of the solid. Next, we want the total surface area of the solid. Now, total surface area, let's identify all the different surfaces. Total surface area is the sum of the different surfaces. So let's see if we can identify the different surfaces. Guys, this solid has a total of 4 surfaces. There's the curved surface in the middle. That's the curved surface of the cylinder. There's the hemisphere surface at the top. And there is the circle surface at the bottom. Tell me if you agree. 4 surfaces. There's the curved surface of the cylinder at the bottom, the hemisphere at the top, and the curved surface at the side for the cylinder, the circle at the bottom of the cylinder, and the hemisphere at the top of the cylinder. If I want to calculate the total surface area, I must add the area of all 3 surfaces. Guys, the total surface area here would be equal to pH. Remember, pH gives me the area for the middle, plus A, that's just the area of the circle at the bottom, plus the area of the hemisphere. Hemisphere. All right. So 3 surfaces. There's the curved surface in the middle. pH is going to give me that. A, that's the area of the bottom, and the area of the hemisphere at the top. P is talking about the perimeter of the cross section, which is a circle. So this is 2 pi r, because the perimeter of a circle is called the circumference, plus H, plus the area at the bottom. The bottom of this thing is a circle, so that's pi r squared, plus the area of the hemisphere cup, which is a half of what? 4 pi r squared. Because the area of the hemisphere is what? 4 times the area of a circle with the same radius. So let's calculate. We have what? 2 times 3.14 times 2.5 times 6, because that is the cylinder, plus, guys, I wonder if you could see this. 2 into this 4 is 2. Pi r squared plus 2 pi r squared is actually 3 pi r squared. So it's 3. You know, I'm really afraid of students. So let me spell it out. So it's pi r squared. So it's what? 3.14 times 2.5 squared plus 2 pi r squared. So it's 2 times 3.14 times 2.5 squared. All right, so just be patient. Do your calculations. Don't make any mistakes. So this is 2 times 3.14 times 2.5 times 6. So this is 94.2. That's the area of the curved surface of the cylinder, plus 3.14 times 2.5 times 2.5. This is 19.625. That's the area of the circle at the bottom, plus 2 times 3.14 times 2.5 times 2.5. And this is plus 39.25. That's the area of the hemisphere at the top. Let's add all three. We have 94.2 plus 19.625 plus 39.25. And we get the total surface area of the solid. Total surface area of the solid is 153.075. All right, I just realized I made a humongous mistake. At C, we're just supposed to calculate the surface area of the hemispheric cup, of the hemisphere cup. So this would be the answer for C, 39.25. That would be the area of the hemisphere cup. And then the rest of it now, the entire thing would be calculating the total surface area of the solid. So I don't want to do it over. I don't want to go it over. Everybody understand?
Yes, sir. Sir?
Yes, sir.
I think there was an error with part A.
With point A. All right,
Part A.
going back up to it. So this is the capacity of the cup. It's a half of a sphere. So it's a half. All right. Okay, you're right. It's supposed to be cube times 2.5. Supposed to be cube. So let's fix it. I don't want to do over this video. So it's 2 times 3.14 times 2.5 times 2.5 times 2.5. And this now is supposed to be divided by 3. All right. You're correct, Jordan. It's a massive error. And this is 32.7 centimeters cube. All right, that is going to affect this answer as well. So this is 32.7, 32.7, subtract. So 117.75 minus 32.7. And this is, the volume of the solid is 85.05. Next, they asked you to calculate the area of the hemisphere. So let me switch to red to show you what would have given you that. All right, so this would be the area of the hemisphere. The formula is a half 4 pi r squared. The area of the hemisphere is 4 pi r squared. Sorry, the area of the sphere is 4 pi r squared. But because the cup is a hemisphere, it's a half of 4 pi r squared. A half of 4 is 2, so it's 2 pi r squared. All right. So we have pi r squared multiplied by 2, you get 39.25. That should have been the answer for the second part. The answer for the third part now, this is the total surface area. This is PH, which is the area of the sides, plus A, the area of the bottom, plus the area of the hemisphere. Penmanship done. Spelling too. Plus the area of the hemisphere. So pH would be 2 pi RH. A, which would be the area of the bottom, pi r square, plus the area of the hemisphere, which we would have calculated to be 39.25. Work that out, and I'm sure you're gonna get back again the 153.075, and this would be centimeters square.